This is SpaceTime, Series 23, Episode 84. Coming up on SpaceTime, a new study warns that alien life would be dangerous to Earthlings, NASA looking at a new mission to the planet Venus, and the Kremlin tests a new anti-satellite weapons system. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has found that alien peptides containing two amino acids commonly found in carbonaceous meteorites would pose a serious threat to human health. The findings, reported in the journal Microorganisms, shows that the immune cell response to these alien peptides was less efficient than the reaction to those commonly found on Earth. The study suggests that extraterrestrial microorganisms, if they exist, could pose an immunological risk to space missions aiming to retrieve samples from other planets and moons. Life on Earth essentially relies on 22 amino acids. The research looked at the reaction of mammalian T-cell immune responses to peptides containing the amino acids isovaline and alpha-amino isobutyric acid, which are commonly found on meteorites. Researchers found T-cells exposed to these alien amino acids had activation levels of just 15% and 61% respectively. That compares to 82% and 91% respectively when exposed to peptides made entirely of amino acids found commonly on Earth. Scientists say the discovery of unusual sugars or amino acids in high abundances on carbonaceous meteorites makes it conceivable that if extraterrestrial microorganisms exist in some of the numerous liquid water reserves now discovered around our solar system, they could contain proteins that include some of these dangerous amino acids. We know that both the Jovian moon Europa and the Saturnian moon Enceladus contain liquid water oceans beneath an icy crust. And there's growing evidence that the red planet Mars also contains at least seasonal liquid water seeps. This is SpaceTime. Still to come, NASA looking at a new mission to Earth's sister planet Venus. And they may talk about demilitarizing space, but the Kremlin's just tested a new anti-satellite weapons system. All that and more coming up on SpaceTime. Okay, imagine the Earth. Now fill the skies with thick sun-obscuring clouds of sulfuric acid. Boil away the oceans by cranking up the temperature to nearly 500 degrees Celsius. And boost the air pressure by 100%, high enough to crush you like a pancake. What you now have is the planet Venus. Venus is Earth's sister planet. They're both similar in size. They're in a similar location in our solar system. They formed in the same part of the solar system, under similar conditions, and from the same material. And they're different in almost every other way. But exactly how these sister planets evolved so differently has been a burning scientific question for decades. Now, a proposed new NASA mission called VERITAS would seek to provide those answers. VERITAS would transform science's understanding of the internal geodynamics that shaped Venus. The mission could also provide new insights into Earth's evolution and even help better understand rocky planets orbiting other stars. The last NASA mission to study Venus' surface was Magellan back in 1994. While it provided tantalizing clues about Venus's geology, the instrumentation available back then couldn't explain the origin of many of the planet's strange surface features. Proposed for launch in 2026, VERITAS would orbit Venus and peer through its obscuring clouds using powerful new state-of-the-art radar systems to create 3D global maps. It would also be equipped with a new near-infrared spectrometer to figure out what the surface is made of. And it would measure the planet's gravitational field to determine the structure of the Venusian interior. Together, these instruments would provide clues to the planet's past and present, as well as geological processes from its core to its surface. On Earth, the rigid crust that envelops the planet is broken into a jigsaw puzzle of tectonic plates all floating on top of the mantle. And convective currents in the mantle help drive the motion of the tectonic surface plates. As some of these plates descend back into the interior of the planet through a process known as subduction, they melt with volcanic outgassing releasing volatiles such as water, nitrogen, carbon dioxide and methane into the atmosphere. Learning more about the geological processes on Venus, where the warm crust is a good analogy for early Earth, when the planet's crustal plates were just beginning to form, could offer a valuable glimpse into how these processes began on Earth. VERITAS Geology Science Team member Professor Joan Stark from Caltech says the biggest mystery is the extent of deformation structures on Venus, areas of rock on the surface that have buckled under immense geological pressure that could be studied to understand the nature of any tectonic activity on the planet. Producing high-resolution three-dimensional topographic maps, VERITAS would bring into focus structures that had previously been too small to resolve. These structures could include raised topography on both sides of strike-slip faults, sort of like the San Andreas Fault, which would be an indicator of major tectonic activity. VERITAS would also look for active surface faulting using interferometric deformation maps, and it would study the vast deformation structures known as tessera. These huge plateau-like features are thought to be analogous to continents on Earth. A leading theory is that Earth's continents formed when iron-rich oceanic crust subducted and melted in the presence of water, producing huge volumes of new, less iron-rich continental crust that rose above the oceans. That's why the continental crust is granitic and ocean crusts are basaltic. VERITAS would construct the first global multispectral maps of Venus's surface composition to determine if Venus's tessera plateaus formed in a similar way to Earth's continents. And if their composition does resemble the continental crust of Earth, scientists could also gain information about Venus's wetter past. See, on Earth, plate tectonics and volcanism go hand in hand. But what about Venus? Confirming that Venus really is volcanically active is long suspected, and understanding how that process works on Venus is another really exciting question that scientists want answered. Using its spectrometer, VERITAS would determine if rocks recently formed from erupting magma, before interactions with the atmosphere would have had time to change their chemical composition. The spectrometer would also search for hotspots from active eruptions, while the radar instrument would look for active faulting, an indication of tectonic activity. Getting to know Venus's volcanoes and the geophysical processes causing them would allow scientists to better understand their impact on the planet's climate, and perhaps even answer another key question. Does the planet's interior still contain large quantities of water like Earth's does? Plate tectonics and volcanism don't just affect how a planet takes shape, they're also intimately tied to a planet's habitability. See, plate tectonics has strongly affected Earth's long-term climate by influencing the processes that keep the atmosphere in balance. Volcanism, which releases volatiles into the atmosphere, and subduction, which recycles those volatiles back into the interior. Also, the formation and erosion of Earth's continents have a major influence on the composition of the oceans and atmosphere. Together, all these processes provide the nutrients and a habitable climate for life to thrive. To unwrap the mysteries of Venus, scientists will need to look under the hood at Venus's interior, at its geologic engine driving its geologic and atmospheric evolution. Only then will scientists discover if Venus and the Earth are fundamentally unique worlds, or if their differences are only cosmetic. And answering that question is key to understanding what makes other rocky planets habitable, and ultimately allow life to emerge. To find out more, Andrew Dunkley speaking with astronomer Professor Fred Watson.
The truth about our sister planet Venus. They call it the sister planet because it's a rocky planet and it's about the same size as Earth. But I think that's where the difference stops, or the similarities stop. The differences are stark.
Indeed they are. Surface temperature 450 degrees Celsius, thick sun-obscuring clouds which are laced with sulfuric acid. It's incredibly different. The surface atmospheric pressure is about 100 times what it is here on Earth, so you'd be flattened. If you were standing on the surface, you'd be very, very squashed. The rocks themselves are probably glowing a dull red because they're so hot. So let me give you a quote from Dr. Suzanne Smrika, who is at the Jet Propulsion Laboratory in Pasadena in California. She says, "Venus is like this cosmic gift of an accident. You have these two planetary bodies, Earth and Venus, that started out nearly the same, but have gone down two completely different evolutionary paths but we don't know why. And that is that's the kind of setting the scene for a space probe, which it's under consideration. It's still at an early stage in its evolution itself. This space probe is being considered for selection under NASA's Discovery program. And actually, it would be JPL, Jet Propulsion Laboratory, that would be the managing organization, as they are for nearly all these interplanetary probes. So what is this spacecraft called? It's a rather nice acronym, actually. It's VERITAS is the name.
Venus Emissivity Radio Science INSAR Topography and Spectroscopy.
That's right. You've got it. This is a whole list of things that it will teach us. Venus Emissivity, Radio Science, INSAR, I'm not sure what that is yet, Topography and Spectroscopy. So basically it is an orbiting spacecraft to follow up on the last big mission to Venus, certainly in terms of studying the surface of the planet. That was the Magellan spacecraft back in 1994. It's hard to believe. It's 26 years ago when that project ended. There are other spacecraft in orbit around Venus at the moment. Venus Express is a European one. There is a Japanese one whose name eludes me at the moment, but they've produced some marvelous insights into the atmosphere of Venus, some remarkable imagery showing things like standing waves in the atmosphere and curious things like that. This would be, I guess, something that will build on all of those. The proposal is that it will be launched in 2026. It will orbit the planet, a state-of-the-art radar system. That's the big new facet on this, because things have moved along since 1994.
And they need radar to be able to really see what's going on, because Venus is just...
That's right. The atmosphere is essentially opaque. So you have to have the radar to produce these detailed maps. There is also going to be a near-infrared spectrometer, which I suspect is what INSAR might be, actually. A near-infrared spectrometer, which will basically analyze what the surface itself is made of. It will give you at least some good insights into the mineral makeup of the surface. But the other thing, which is what we're seeing with Juno in orbit around Jupiter, by knowing the details of the spacecraft's orbit, you can essentially plot the gravitational field of Venus and look in more detail than we have at the moment at the internal structure of Venus, because the gravitational field is different depending on what the structure is. So all of these instruments and facilities will basically, we hope, give us some idea of how the planet has evolved geologically, what the geological processes are that are going on at the moment, and as they say, from its core to its surface. So it's a holistic look at the planet Venus. There are lots of things we want to know. Is there plate tectonics on Venus? This is something that's not really well known. So all of these questions are on the table for the VERITAS mission. So I hope in 6 years' time, Andrew, when my knee is fully recovered, you and I might be talking about the launch of this spacecraft.
Indeed. Are they going to try and find out what went wrong with Venus? Like, as they say, both Earth and Venus started out pretty much the same and just went totally opposite directions. We became a livable world with water and oxygen and all the things needed to create life. And Venus went, nah, I'm going to trash the lot. You can all burn in hell. Or they just burnt too much coal to create electricity. Not that we would ever do that.
Indeed, that's right.
Could we learn anything from the demise of Venus as a potentially livable world that might help us?
Of course. That's why we study these rocky planets, because we've got two opposite extremes on either side of us, Mars and Venus. And the more we know about them, the more we understand the atmosphere of our own planet and the geology of our own planet.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. Still to come, Russia might be calling for the banning of weapons in space, yet there's growing evidence the Kremlin's been testing new anti-satellite weapon systems. And China launches another high-resolution surveillance satellite, increasing its eyes in the sky. All that and more still to come on Space Time. Okay, let's take a break from our show for a word from our sponsor, ExpressVPN, rated #1 by TechRadar. You may be wondering why you need a virtual private network. Well, it's in the name. It's all about privacy. Do you really want big brother tech companies, hackers, governments, and who knows who else snooping in on your online activities? Now, you might not have anything to hide, but it's still really creepy, and it could be dangerous for you and those you care about. Also, how often do you run across a website and you want to get information from it, but you find out that they're geo-blocked? It's all very frustrating, and it's becoming an increasing problem. And that's where ExpressVPN can help you. ExpressVPN's a simple and efficient way to protect your online privacy. It's internet without borders from the world's leading VPN provider. So, protect your online privacy today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more. And of course, you'll find the link details in the show notes and on our website. That's tryexpressvpn.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
Moscow has conducted a space-based anti-satellite weapons test, firing a projectile from its Cosmos 2543 satellite. The controversial Cosmos 2543 was launched from the Plesetsk Cosmodrome back in November 2019 as part of the Kremlin's so-called Inspector series spacecraft. These are spacecraft designed to change their orbits so they can allegedly inspect and study the condition of other Russian satellites in orbit. However, earlier this year, Washington raised concerns about the spacecraft's true nature after it spotted the Kremlin maneuvering the Cosmos 2543 and another satellite, the Cosmos 2542, close to an American satellite, undoubtedly hoping the United States wasn't watching. The Pentagon's concerned that these Russian satellites are actually designed to install electronics and take control of American and Allied satellites, or attach tracking devices or possibly even explosives to them. Washington says that Moscow's actions by firing a projectile impactor from the Cosmos 2543 contradicts the Kremlin's call for outer space arms control. This is Space Time. Still to come, China's growing eyes in the sky, and later in the science report, a new study confirms that New Zealand's melting glaciers are 10 times more likely to have been caused by global warming. All that and more still to come on Space Time. China has launched another high-resolution surveillance satellite as part of its growing constellation of almost 100 eyes in the sky, keeping a close watch on Beijing's friends and enemies. The new Gofeng 904 optical remote sensing satellite was launched aboard a Long March 2D rocket from the Zhuquan Satellite Launch Center in northwestern China's Gansu province. The spacecraft was placed into a 494 by 513 kilometre high orbit. Beijing claims the new satellite will mainly be used for land surveys, crop yield estimations, as well as disaster prevention and mitigation. But military analysts claim the satellite will also be used to track adversaries sailing in places like the South China Sea, the Straits of Taiwan, and the East China Sea, as well as monitoring China's growing interests in the Western Pacific and Indian Oceans. Also aboard for the launch was a small secondary payload, the Xinhua satellite, which will study Earth's gravity and atmosphere. Understanding the planet's gravitational fields and atmospheric environment helps improve the accuracy of missile targeting systems. The mission also marked the 50th launch of a Long March 2D rocket and the 342nd launch of a member of the Long March rocket family. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. Well, it seems whole chunks of the globe have come to a stop for COVID-19 lockdowns, causing what's now the longest and most prominent reduction in man-made noise on record. A report in the journal Science measured vibrations caused by human activity, finding that global lockdowns have reduced seismic noise around the planet by up to 50%. The findings are based on data collected from 268 seismic monitoring stations in 117 countries around the world. As countries began implementing lockdowns to prevent the further spread of COVID-19 from China, a clear pattern started to emerge. This so-called anthropause, as it's become known, first became noticeable at the Chinese epicenter in late January, followed by countries in Europe and the rest of the world over March, April and May as the full extent of the pandemic became known. In all, 185 seismic monitoring stations recorded significant drops in the high-frequency anthropogenic signal, correlating to lockdowns in those regions. It was most pronounced in high-density areas such as cities, but researchers say the effect was also noticeable in more low-density rural areas, even in stations that are incredibly isolated, such as the middle of the Schwarzwald, Germany's Black Forest. Meanwhile, a new study looking at your chances of getting COVID-19 in a commuter situation, such as aboard a train, bus or aircraft, have found that sitting within 3 seats of an infected person meant you have on average a 0.32% chance of catching the virus. The study also showed that passengers travelling in seats directly adjacent to an infected passenger suffered the highest level of transmission, with an average 3.5% chance of contracting the illness. However, it also found that sitting on a seat previously occupied by an infected person only increased your chances of contracting COVID-19 by 0.075%, much lower than previously thought. The findings by scientists from the University of Southampton are reported in the journal Clinical Infectious Diseases. A new study has concluded that New Zealand's melting glaciers were 10 times more likely to be caused by man-made global warming than by any other process. The findings, reported in the journal Nature Climate Change, show that this increased likelihood is driven by present-day temperatures being around 1 degree higher than before the Industrial Revolution. The study suggests that as the Earth gets warmer, there will be an increasingly visible human fingerprint on extreme glacier mass loss over coming decades. Paleontologists have discovered a new species of theropod dinosaur in Portugal. The new Carcharodontosaurian dinosaur, named Lucivenator santosi, is based on fossil fragments from 2 individuals from the Jurassic. One of the fossils has been dated to around 153 million years ago, and the other to around 145 million years ago. The ancient predators reported in the Journal of Vertebrate Paleontology were each around 3.5 metres long and 1 metre tall. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favourite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.